in two of the safety equipments that are used the most frequently in labs, then we can tell you a bit more about those. So let's start with the ducted fume hood. The ducted fume hood is a fume hood in which you will work with chemicals and the air will be extracted to the outside. So all the chemical hazards that are coming free in the lab, they will be exhausted by a ventilation to the outside air. So there really is a mechanical ventilation, and you really need to connect that hood with a system in the infrastructure of the building. What is really important and really something that I would like to tell through this webinar is the fact that often we think about risk assessment only the risk that we are exposed to in the lab. When we talk about risk, there is not only a risk in the lab, there is also a risk outside the lab. All the air that we extract to the outside will be released in our atmosphere. So there is also a risk outside the laboratory. So that's also important to take into account, and it's also an awareness that people need to have when choosing the adapted safety equipment. Of course, the risk in the lab is not completely gone when you use ducted fume hoods. You will exhaust the air to the outside, but then you have to pull clean air back into the laboratory through an HVAC system, and that air will be heated again or cooled again, which will result as well in a high energy cost. So a ducted fume hood is a good solution. It will keep you safe. It's important it's an important safety equipment that can be used. But it depends again on the risk that you're exposed to, and then you need to know what to use. But on the next slide, that will maybe appear for some of you in a few seconds, you will see some European standards about ducted fume hoods. Ducted fume hoods, they need to be tested in many ways. The European standard for ducted fume hoods is the EN 14175, and I'm sure that many of you know this standard. But there are many different tests that have to be performed in order to assure the safety, in order to minimize the risk. And so we're going to talk more about part 3 of this standard, which is about containment, a test that we perform about containment. So a ducted fume hood, for the people who don't see the slide, normally it should appear just in a minute. The principle of a containment test, which of course creates that air barrier, is by releasing some chemical products. In this case, in the standard, it's SF6, which is hexafluoror. It's quite a heavy chemical. It's released in the enclosure, and we will check, or we will control what the amount of that chemical is that is still coming free in front, so in the opening of the front of the fume hood. So that's something we're going to test in order to assure a good containment. So there are multiple protocols. There is internal plan, external plan, in order to test this. So to sum up, the ducted fume hood, the big advantage of a ducted fume hood is the fact that you're not limited. If you use large quantities of chemicals, they will all be evacuated to the outside. Of course, you have to think about the fact that it's not really a green solution because you extract all these chemicals into the atmosphere, but sometimes there is no other solution, and you need to use a ducted fume hood in order to be safe, to be working safe in the lab. So that's really a good example, a good advantage of ducted fume hood. Inconvenience, however, of ducted fume hoods is the fact that they consume a lot of energy, because you need to compensate the air. All the air is extracted to the outside. You need to recompensate that by air that's coming back into the lab, that has to be heated again, that has to be vented, that has to be cooled again. So you really are consuming a lot of air, which is very high energy consuming. And of course, it's not really a flexible solution. You're fixed. The hood is a fixed ducted system. The other solution, one of the safety solutions that we saw in the list in order to prevent people to be exposed to hazardous chemicals, is a ductless fume hood. And a ductless fume hood works in a different way. A ductless fume hood is an independent system that you can place on, for example, your lab table, and it will recycle the air. It will not consume any air compared to a ducted fume hood. So it will only use the air available already in the lab. And then you ask, of course, the question, where do those chemicals go? Where do those chemical vapors go? Well, they will be adsorbed by an activated carbon filter. If you would use powders or particles, they will be captured by particulate filters such as a HEPA or an ULPA filter. So this is really completely different technology, which has a lot of different advantages compared to a ducted fume hood. But the main principle is that it keeps you safe, again, by a good containment. Just to give you an idea about the different standards, again, that these ductless fume hoods are exposed to or that they use. Of course, there is one standard that is the most stringent one, which is the French standard. It's the AFNOR NFX 15211. And then there are a few international standards as well, which is one for England, for China, and for the US. There are some people from the US who are as well connected. This may be one of the rules or the international standards that you may know. Maybe interesting for you to know as well, there will be a European standard for ducted fume hoods. Hopefully it will be published soon, which will be a combination of the Chinese standard for ducted fume hood and a combination of the French one. Again, if we talk about containment, because that's what this is all about. It's about minimizing the risk. So this air barrier that you have between the chemical products and the person in the lab must be tested as well on a ductless fume hood. So how do we do that? We apply exactly the same protocol that is performed on the ducted fume hoods, which is part 3 of the EN 14175. So what do we do in a ductless fume hood? We are going to test again with SF6 and see if there is less than 0.1 ppm of that chemical released in front of the user. And we are going to check as well what the air phase velocity of the fume hood is. And the air phase velocity is the airflow through the cabinet, and it must always be between 0.4 and 0.6 meters per second when you have a fixed opening. If there would be a sliding sash opening, it has to be higher than 0.4 meters per second. Otherwise, you have a risk of the chemicals coming to the people or the person working with the hood. As I mentioned, you have two ways in which you are protected. You have the air barrier, so the containment, but also the chemicals, they have to go somewhere. On a ducted fume hood, they will be extracted to the outside air. On a ductless fume hood, they will be captured by an activated carbon filter or by a HEPA filter. Just to give you some more information about how we test that, this is a test that we perform in order to know that there are no chemicals released after the carbon filter. So after the air has passed through the filters, that's how we know that you are in complete safety. So these are tested, for example, in the lab here at our lab by our R&D department with isopropanol and cyclohexane. And filters for acids we use hydrochloric acid to test. We are always going to look for a result under 1% of the exposure limit value of the product that is released or that is used in the fume hood. So that's just to give you an idea that we not only have to test the containment, but we also have to test the filter efficiency and the way the chemicals are or the filter, the activated carbon filter is his performance is tested. So to sum up again, for a ductless fume hood, there are numerous advantages, which is of course the fact that it's mobile, it's flexible, it's plug in and play. It comes in, you put it on your table, and you can work. It's operational, so it's very easy to relocate. The energy consumption is very low, and that's thanks to the fact that you're not going to consume any air. So you're only going to use the air present in the laboratory. And so there is no planification, there are no works to be done. For a ducted fume hood, you have to think about the infrastructure, the connection to the HVAC, etc. With a ductless fume hood, that's not the case. The only inconvenience of a ductless fume hood, and that's why risk assessment again is so important. Know exactly what you're doing in those hoods, is the fact that huge evaporations are not allowed, because otherwise the carbon filters will be saturated very quickly, and then we cannot guarantee the safety of the people working with the chemicals.